one of you guys to write such a document and hand it to us.
I was thinking of plugging Ron. He's not here, right? So I can.
Yes.
So another thing that we talked about in that vein was also the engineering advisor, or maybe there are other peoples at the institution that could potentially put together a list of courses that the institution offers that students going on into engineering graduate programs or something that the school might expect that the students would have had. So maybe they're not a physics major, but if you apply to most engineering programs, they expect that you've had a year of physics or a year of chemistry or things like that. And so looking around at the courses that are offered and sort of helping students say, okay, you're thinking about engineering? These are the courses that we do have that maybe you should consider fitting in your schedule. And then in terms of another aspect of this question is outside of curricular activities, what are things that we can do to support students? So we talked about students participating in outside engineering competitions. There was building a solar-powered structure. Carleton St. Olaf students did a Hyperloop competition. But the issue with that is it requires money. The funding for building those sorts of things need to come from somewhere, and especially if it's going to be sustainable, how would that happen? The use of makerspaces and making the shop accessible to students, and the fact that a lot of these spaces tend to be sort of nooks and crannies somewhere, and they're not necessarily very visible in other departments, and students across campus don't necessarily know that they exist. And so are there ways that we can make those spaces for students to express their creativity more known? And we also, related to that, we talked about issues of sustainability in terms of, is student interest motivating it? What happens when they graduate? If students are pushing for these spaces versus having a dedicated staff member to support and create continuity. We also talked about club-type organizations like Engineers Without Borders, and whether or not those clubs are connected at all with the engineering advisors. And again, with programs like that, are there issues of sustainability? When students lose interest, do they just die? And so you've lost that avenue of connection. And then looking at engineering in non-traditional places. So encouraging students to get involved with set design, for example. Set design in theater departments. Art classes that are working with materials and trying to express creativity and learning how to work with different materials, and also student jobs. So Mark has a student assistant that works with him. We also have our lab manager has a background in electronics and also has a student worker. And so those might be other ways that you can support students interested in engineering and design.
We're the table to talk about 3-2 engineering programs, and I'll just outline the topics we talked about before going into a little bit of detail. We started talking about what was the initial motivation for 3-2 programs, which might be 40 years ago in many cases. It's circa 40 years ago. We talked about the size of the 3-2 programs, their effectiveness now, both in terms of the number of students who participate. We talked about some of the issues around them. For example, whether getting a BA and a BS degree versus getting a BA and a master's degree. And we sketched out some attractive ideas for making the programs stronger. And now to go into just a little bit of detail. The initial motivation seems to have been largely to recruit students to the college. And at some point it was effective at doing that, and it may still be.
Do you mean to the four-year school or to the master's?
To the four-year, to the McAllister part of the McAllister-Washview program. And another purpose was to give students who might not be prepared to succeed in an devoted engineering program time to mature academically. So to give them some time to catch up with their eventual with their eventual classmates. And perhaps to allow students to explore other areas of science that they might not have heard about. A lot of first-generation students have heard about engineering, but other forms of science are abstract to them. Consistently, there's a pattern of 0 to few students participating in these programs. So I think maybe you hold the record to a year?
Oh, no, 1 year.
1 year, okay.
And that's recent.
So students have trouble participating. There's a number of good reasons for that, some of which relate to the changing academic structure, or the changing structure in academics across the country. Things like study abroad, the critical importance of financial aid, alternatives such as computer science, which provide a vocational path for students directly from many liberal arts colleges. Wellesley has had success by printing the numbers of students who actually participate in the 3-2 programs in their catalog or in the website description. Something that had never occurred to me because zeros get depressing after a while. But I think that would send a message of reality to students. And some of the issues we talked about, entrance to engineering programs has become now competitive. I know at Macalester it used to be a formality to apply and be accepted. It would happen in a week. And now it's not guaranteed, and I gather there's much ill will towards Columbia, which has basically suspended that whole idea of making it automatic. That in many ways a master's degree would be a more appropriate engineering degree for our students, but it's hard to succeed in such programs without having had undergraduate engineering courses, genuine engineering courses.
Quick question, because I just learned from Marty that there are certain parts of engineering, such as civil and parts of mechanical, where you actually need the accredited BS degree, so the masters alone will not do the trick.
Well, that may be.
Well, it depends on the master's program.
But it also depends what you're doing.
Right. So being part of city regulation type building things, and so that.
I think there's definitely areas where ABET accreditation is more important than others. So if you're not going to, civil engineering, environmental engineering, really important. If you're computer engineering, electrical engineering, there's a lot you can do without that ABET accreditation.
Sure, but the advice of my general advice is, well, you might as well get the Middlebury BA and then get a master's. And now it turns out that that might not always do the trick.
I think that works though also because down the road there's alternatives. If you have the right kind of engineering experience, and I have never been through this, but I think you can put in some sort of petition to have what you've done be acknowledged as equivalent. So there are mechanisms, I'm not sure of exactly what they are, but I'm not sure you need to get hung up on.
Some schools will not admit you unless you have an accredited engineering degree. Other schools will.
Right, that's really what I was going to say. It depends a lot on the school, and it's not even necessarily that the better schools require ABET. It's kind of a spotty mix. I think the student, I know a student who graduated with a degree in music, a Bachelor of Arts in Music, who went to graduate school in engineering, in civil engineering, and is a civil engineer now. So it is possible to do, but had to take a particular path.
And then we talked about some attractive ideas for making the programs more meaningful. And some of these there was consensus about, and others not so much. So one that there wasn't complete consensus about was reorienting the programs towards a master's degree. And we talked about the various ways of doing that, and especially about the Penn program that Haverford and Bryn Mawr participate in. So there's so many people from, but then it was pointed out that it's not really a 4-1 program as advertised. It's really a 4-2 program. And it's really hard for students to get enough engineering courses in their 4-year part of that program to be able to do well, to be able to get along with the rest of their classmates, so to speak. So there wasn't complete consensus about that. there was a sense that taking engineering courses while you're an undergraduate is helpful. And Wellesley students, for example, can take engineering courses at the Olin College of Engineering, which is very close physically, and that works out how? I mean, it's worked out well.
And MIT.
At taking courses at MIT, yeah. And for some of us, that might be harder. Kenyon Williams, a little bit harder to take the subway to get to the engineering school, the main line. And then I'll end with something that I find an attractive idea, but which I will not say there was any consensus about. And that is, for many of us, this is the first time we've ever had any contact with other people who've been engineering liaison for 20 years, or for 10 years, or for 5 years. And so we've never had an opportunity to compare our experiences, and our experiences seem to be of a kind. We seem to share the same experiences. And we seem to feel that, well, not we seem to feel, we feel that the programs are obsolete, that they may be working marginally and producing 1 or 2 students a year at some schools who go through the program, so we can't say they don't work at all, but they don't have a substantial impact on large numbers of students or even handfuls of students. And now I'll switch to my own view. At Macalester, I've come to the conclusion over the last few years that having the Engineering 3-2 program has been a detriment because it allows the administration to pretend we have engineering when in fact we do not. It has some advising advantages, but I've come to the conclusion that those are outweighed by that detriment of pretending to have an engineering program when we don't. And I would find an attractive idea to have like-minded people here write a letter, not making a policy position, but just something which shows this, the breadth of these experiences across institutions. A letter saying, these programs need to be restructured from the ground up. The status quo is not adequate, should not be supported anymore.
Can I add a comment to that?
Please.
So I think historically at Smith, we had a 3-2 program. I think it fit into this where very few people did it. I don't know the numbers, but I've met a number of alums who did go on for master's degrees before we had engineering at Smith and did terrific in them, and they're really well-performing engineers out there in the world. And I suspect all of your schools have the same story, but we haven't documented it. And so one idea is trying to get a hold of who are the alums from these schools that actually went on to master's degrees in engineering, and using some of that in place of, when you talk to the parents, in place of saying, oh, we have this 3-2 program, you can say, well, you can major in physics here and go on and do engineering if you want to, and here's some examples of people who did a really good job at that. And then,
well, of course, you can major in physics and go on, and you can major in music, you were saying?
Yeah.
Kara was saying,
Yeah.
you can major in music and do these things. And for myself, I majored in physics and philosophy and did biomedical engineering.
yeah.
It's true, you can go on and do things. That's not a program. And,
Absolutely.
And one of the important reasons to have the 3-2 program initially was recruitment. And I think it's a very different story if you say, oh, you can come here and after 3 years, go to an engineering school, than to say, oh, well, you're going to major in physics first. Right? For a lot of students, that's way too daunting, and especially for students from, say, first generation, who are first generation students and the like. So to say that we have an engineering program because people have successfully found a way around the actual engineering program, I don't see that as
I'm
attractive.
sorry, I wasn't trying to say that. I was just saying it's the recruiting piece that could replace it, but I agree with the other things you said.
Maybe we need a sidebar for this conversation to continue. I'm just conscious of the time. So, yeah, sorry. Right, and we have 2 more tables to go. So we'll continue that one over lunch.
Well, and I think during the panel this afternoon.
Yeah, and definitely during the panel.
See if they come to the same conclusion.
Yeah, go ahead. Yeah.
So at this table, we were talking about engaging non-engineering students in engineering, and we started out by talking about why is that an important thing to do. And we realized that most students at liberal arts colleges don't understand either what engineering is or how important and widespread it is in the world. They certainly don't understand the way that engineers work in highly diverse teams that are probably more diverse than the teams that are involved even in interdisciplinary science. Through our discussion was mostly aimed at ways to engage non-engineering students via coursework. So maybe in the afternoon session, you can make sure to set aside time to talk about non-course approaches. But through these courses, we would hope that students would gain an understanding of how interesting stories about engineering are. They're just absolutely fascinating, many of them. And occasionally, you might spark early interest in some of these students that then would say, oh, I didn't think I was interested in engineering, but maybe I am going to follow a path in that direction. One big surprise to me was that the NSF has data that says that if you have engineering in the title of such a course, it would be a very bad idea.
It's nothing as if it's the American Society for Engineering Education, ASEE, the Technological and Engineering Literacy Division. If you search in the proceedings, you'll find some of those references.
And the reason, I guess, we should just say, is because the term engineering in the course will be a turnoff to students because of science phobia or engineering dislike. They don't want to be associated with engineering, but they would actually benefit from learning about it. They just don't want to go take a course with that.
So somehow we have to fool them into taking the course without telling them what it is.
Design.
So we talked about the course goals, one of which would be to make engineering more, make it clear that it has a human side, that there's a real human narrative. Another would be, how does engineering happen today? Where do the problems come from? There was some difference of opinion about how important is it to make the distinction between engineering and science, and that both of them involve an iterative process. In engineering, there's this iterative design process. In science, there's an iterative hypothesis testing process, and that might be an important component of a course aimed at non-engineers. Probably you want to get people, because we're coming from a liberal arts perspective, to try to think at a kind of a meta level about engineering and the process of engineering. Certainly, we want to try to give the students some insight into how engineers think. We probably, in the course, in the process of a single course, can't actually get them to think like engineers too much, but maybe a little bit. Larry brought up this interesting game that he has helped develop called the Delta Design game, which involves tries to simulate the negotiation process on a big engineering project. We talked about who could teach such a course, and I think there was some consensus that somebody without an engineering background maybe really could teach this course, although it would be better to at least have some advising from somebody who does have an engineering background. The hands-on element to the course seems to be critical. So people at the table who have that engineering background said, if you want to give people an insight into the way engineers think, you must have the hands-on element. That's resource expensive, but you've got to have it. And as part of that, failure has to be part of that process, because that's a critical part of the engineering process. You have to let them fail.
Some of them.
And failure,
Not all of them.
failure may be a more critical part of the iterative process in engineering than it is in science. That's maybe debatable, but it's certainly absolutely critical. And we just started to talk about how important is it to include math as part of this, but we didn't get far enough to reach any conclusions.
Good summary.
Let's work.
So our table, in essence, picks up, to some extent, where the third table where Walter left off. And I'm not sure to what extent we got to solutions, but we came up with 5 questions, and so I'll pose those questions. The first one was how to bring engineering and engineers, I guess I should say, to teach at a liberal arts college. Thinking from the vantage that at a liberal arts college, the resources both intellectual and to some extent financial, might be limited for that engineer to come and be teaching. And one idea that was floated was much like teaching systems in the languages. Perhaps we could have people come. So again, we didn't focus too much on solutions, I don't think. We're fleshing out, we're just presenting the questions. The second question grew from this vantage of how can we put engineering into liberal arts courses, given that many of those liberal arts courses are already fairly dense, particularly in terms of content. And so that led to a focus more on mindset. How can we bring the engineering mindset into the liberal arts courses? And there was several suggestions or examples that are done, such as Grinnell has a faculty-to-faculty tutoring relationship where two faculty basically join in a relationship where one might know something more about a topic than another, and they come together and over a period of weeks, a semester, that knowledge gets shared. Another example given was Brittany with co-taught courses, and you could have just two instructors coming together. There was another question, which was what is the mindset of an engineer? And there, again, we didn't work toward an answer, but ideas that were floated was this notion of quantitative reasoning, the iterative process, and to some extent a tolerance of ambiguity, that there might not be one single right answer, and that would be what we would want to try to bring into our courses. Another question was how to interest students, and the sort of, again, to the extent that we talked about solutions, it was the focus on problem solving, solving the world's problems, and our students are very interested in solving problems, doing something with the knowledge that they are gaining. And the final question was whether there are barriers, particularly amongst faculty. Do non-science faculty, non-STEM faculty feel threatened by trying to bring in engineering to that? And again, we didn't work toward any particular solution. And this is where it didn't get discussed at the table, but it's something that Walter had mentioned about how do we go about fooling students. And I have this interesting, most of you are engineers or physicists, and I have the interesting problem that if I put biophysics or physics in any of my biology titles, my enrollments just plummet. So I have to find sneaky ways to bring in engineering and physics. I don't have any solutions, but the biologists certainly have this problem of trying to bring in other disciplines and having students do it. Okay.
Well, thanks.